So, welcome to the 24th virtual meetup. Today, we will be having Attila. Before starting, a huge shout out to Browser Stack, our exclusive sponsor for all our community events and premier sponsor for conferences. Hi, Attila.
Hi everyone,
How
how
are
are you?
you?
I'm good, thank you. Doing great.
Perfect. Before the start, which is creating maintainable Selenium test is a challenging task. Make sure you watch the session till the end because Atelia is going to share the language features that Kotlin provides to overcome this challenge. You can share your screen and then we are good to go.
So, first of all, I would like to thank you for inviting me. It's a pleasure to be here today. And I'm going to talk about two of my favorite subjects, the DSL and code generation in Kotlin for Selenium tests. And the goal here is to get to know Kotlin features and some concept and how to utilize them to write clean and maintainable Selenium code. I will share what I find particularly interesting and useful, although I'm still exploring some of the features. And please post your questions during the presentation, and hopefully at the end, we will have some time to address them. So, about me, I'm a test automation consultant. I started my testing journey in 2009 at the university while I was studying, and I've been working in various industry at multinational companies, small startups, in different industries, and currently I'm working in healthcare. I am a Kotlin enthusiast. I have a soft spot for Kotlin and its ever-evolving ecosystem, and I do love spending my free time on my Kotlin Selenium pet project. You can find me on LinkedIn, GitHub, and Stack Overflow. I occasionally do check Kotlin Selenium questions on Stack Overflow and try to answer them. So today's agenda will be some showcase of the Kotlin language features. I will try to do my best to break down the concepts because it might be a bit overwhelming if you are new to Kotlin and functional programming. And after we got to know some basic features of the language, we will deep dive into the page object design pattern, the concept and the core idea of it, some background of the page factory, utility class in the Selenium package, and some drawbacks and future considerations. Then we will be moving on to the domain-specific languages. We will start with the equivalent Java builder pattern. Then we will look into the idiomatic Kotlin code. And finally, we will touch upon KSP, Kotlin Symbol Processing, a bit of metaprogramming theory, and I will demonstrate how to use it. So I will be presenting some code in the IDE. I will present the problem and some solutions that I find particularly useful. So we will be spending most of our time in the IDE, but I might jump back to the slides if I need to. So we have a lot to unpack, so without further ado, let's get right into it. So I have created a Gradle project in my IntelliJ IDE. Sorry, yes. And I have created some Java and Kotlin sources. And I have pulled in some dependencies. Some are coming from my library. There is the JUnit one. I think most of you know about that. I'm using an assertion library written in Kotlin. It's called Kotest. And basically, pretty much that's it. Let's start with the warm-up exercise, which is this file. So in Kotlin, you don't need to create a class to just hold a single function. Instead, you can just create a file with a Qt extension and write your function something like this. And what happens behind the scenes, the compiler, this is the Kotlin bytecode. If I decompile it, you will see actually Kotlin created a warm-up Qt file and placed this say hello as a static function there. And here is the function body. And I can call this function as a regular function in my main. And this main is also a top-level function, which is, if I look into this decompile bytecode again, okay, it's not picking up. One more time. It's just a wrapper of this main. So we have the public static void main that wraps and calls this main right here. So Kotlin does a lot of things behind the screen, and it makes the code cleaner and more compact. Also, you can do a bit of refactor to make it even more shorter and compact. So this is a single expression function. As the name suggests, it's just a single expression. So you can remove the braces. If there is a return time, there is none. In this case, it's a unit. So basically, it's a void in Java. The compiler is smart enough to infer the return time. And if you have a return keyword, you can remove that as well. So you can have functions just like that, and you can actually write a bunch of lines here and return in a single expression. Moving on to the next Kotlin feature, the extension functions. So you don't need to have the source code to be able to extend classes. So you can extend, for example, the WebDriver or web element, even though you don't have access to it. The way to do it, you define the class name, then after a dot, you write the function name and the parameter. And what I'm doing here is basically just creating alias functions for open and type. So if you don't like the get or the send case, you can just write something like this, and you can call. I have two mains, so let me comment this out. So you can call these functions as normal functions. They are not part of the Selenium library, but in a sense, they look like they are. So the next type of functions I'm going to talk about, the scope functions. So notice that we have the options repeated in this code block. Luckily, Kotlin has a solution to cut off this repetition with the help of scope functions. So we have the first one, which is called with. You can read this piece of code like this. With options, do execute the following. And the return type of this expression will be the last line. And this will be actually a void, so there is no use of it. And you can use with for performing multiple operations on the same object. Another scope function that is very useful is the apply. You can use apply for initializing and configuring the object. So here I have the same function, but now I'm creating the Chrome options. I say apply and play the same line of codes, and I just return with it. So apply will always return with the receiver type. This called receiver type. And you can call these functions as normal functions. So we will be using top, extension, and scope functions during this presentation. And we will be working on our code to make it cleaner, maintainable, and very expressive. So that's the idea. And let's move on to the page object model in Java first. And I will tell you what I find a bit challenging when it comes to page object in Java, and I will give you a solution in Kotlin. So I believe many of you seen page object like this, where we have some locators on top, where we define the locator strategy and the locator name. And the idea behind the page object model is that you have a single repository, a class like this, that represents the page, the element on the page, and the action that you can take with the page. For example, on this login page, you can log in. As I mentioned, Page Factory is by default lives in the Selenium support package. So it's right here. So it has a interesting history because it was never meant to be an official support for page object model. It was rather just an idea how one could create page objects. But it landed up in the library and people started to use it. So it was hard to remove it after that. And it was admitted by Simon Stewart, the Selenium tech lead, that it's not the best implementation. It's a bit suboptimal. The idea is great, but it has some limitations. As I read, for example, the caching is not the strongest part of it. And also, you might have seen stale element reference exceptions here and there when using Page Factory. It's very annoying, and you need to come up with some solution for that. Usually, you need to relocate the element. Other than that, it's really convenient to use it because it's in the support package. It's very intuitive and cuts the boilerplate. So I've been using Page Factory for years, so I have my fair share. But I also learned it's not the ideal way of doing things. So that's one thing. And the other thing is that the Selenium team is not maintaining the support package anymore, and it's been removed from the C# binding already. And they are thinking of removing from the Java binding as well Selenium in Selenium 5 or 6, together with the expected conditions. So then what can we do if, let's say, Page Factory will be gone in the coming releases? Luckily, in Kotlin, we have a design pattern built into the language. It's called delegation. So as you can see, I have no annotations here. By the way, annotations is very much limited because you cannot write code into annotations. Annotation needs to be compile time constants, and you cannot write dynamic locators either. But here I don't have any notations. I have my properties, and I am delegating the creation of these properties by this keyword by and a function, which the function name suggests is a locator strategy, and here is my locator. So basically, there is another helper object referred as a delegate, will do something behind the scenes and create these web elements for me whenever I need. And I'm going to show you the corresponding test class. By the way, we are automating the source.com login page. I can show you quickly. So this is the page. And we just log in and verifying if these web-labs are visible. Great. So in my test, I'm using the login page, login function, and I have some constant for the username and password. And I'm calling this function. And if I run it, it opens the browser, does the login, and we are doing the verification. In the end, should be coming from the mentioned core test library. I like it very much because it's very expressive and easy to read. All right. Let's have a look at another example. Delegation with synchronization. The nice thing about delegation that you can write code after opening up the function. So you can write program code to do synchronization. So what I'm doing here is that I'm finding a button with the ID of button, and I'm waiting to be clickable. And clickable is an extension property. So you have extension functions, but you can also create extension properties. So here I have a web element that I'm extending with a property named clickable, which is nothing else than is displayed and is enabled. So that's the same as the expected conditions wait to be clickable function call. And the corresponding page would be this one. So if I refresh it, you will see the button will show up 2 seconds later, and it becomes clickable another 2 seconds. So that's what we are trying to automate here. And here is the test case. So I'm just initiating the delete button page, and I click on it, and I will verify if it has the right text. So let's see if this works. It did. I'm going to show you one more example where I have multiple elements. So these locator functions are polymorphic. So you can either call it with a single element or list of elements. Web elements, it's nothing else, just a type alias for list of elements. And I can briefly show you these locator functions. So I have all defined in this file for different locator strategies, both for list of elements and single element. I will show you first the page that I'm automating. So I have these images popping up roughly in every half a second, and I want to wait until the last image pops up. And then I will do some verification. So this is the corresponding test class. Once again, I'm initiating the page, and I just iterate through and verify if the images has the right alt attribute with the index. So let's run it. And then I will run this example without synchronization. So this passed. Let's remove the synchronization part and run it again. It immediately failed because it didn't wait until the last element showed up. So I find this particularly useful. And basically you can write different strategy how to wait for elements, because it refers to the actual element. So you have access to is displayed and is enabled, and you can combine them. And you don't need to use the expected condition class. All right. Now I will show you the builder pattern before moving on to the domain-specific languages in Kotlin. So once again, I have a page factory implementation in Java, but with the builder pattern. You might have seen builder pattern before. It's very common in Java libraries. Even Selenium has the Chrome driver builder, for example. So the idea is that you have some function that always returns with the page itself. In our case, it's a login page. So you can say login page, login as with the username, and then you say with the password. And the key is to return with this in the end. So let's see the usage of this builder pattern in the test. So here I'm just creating a new instance and then calling the function. However, I found this not as optimal because one could misuse the API. For example, accidentally, what if I doing this 3 times calling the login as function? I'm going to put a breakpoint here, so we will be able to see what's happening in the browser. And if you have guessed it will type username 3 times, then you are right. Okay. And there you have it. So there is no compile time check about API usage. So it's easy to misuse, and it will turn out only runtime if the API is actually able to create the instance that you want. Other than that, it's very easy to use, again, because it's intuitive. You can change the method. So that's very much a pro thing when it comes to this pattern. But we can make it even better with Kotlin, called DSLs, the idiomatic way of doing the builder pattern in Kotlin. So I will demonstrate this class first. So I have a login page one more time, takes the driver, and I have the login method. And now I have a function blocked open here. And I can say, okay, username equals the username, password equals password. And how it works behind the logins. So I have this login function, which takes a login scope, which is a super simple class. It only holds a username and password property. And what I'm saying here, please take this login scope, and with the dot and with this expression, I'm attaching a piece of function to this class, and then I can access the username and password in my test, and I can do the assignment. And in the method body, first, I'm creating this login scope, again, applying the block, and then I'm sending in the keys, and then clicking on the button. This part is same as before. So if I run this test, it will be working, but more importantly, if I do mistakes here, this will be working. It's not going to send the username or password many times into the input fields. I have another variant of this login function. In this case, I'm abstracting the way I'm calling the login. So before, we had the login page initiated in the test, but now I'm doing the initiation in the login function itself. So here I creating the login scope, again applying the block of code, creating a login page, and I'm using experimental feature in Kotlin called context receivers to cut off the number of parameters, and basically I'm doing some dependency injection under the hood. Now I have the driver, and I can refer this driver with this @WebDriver piece of code, and the rest, it should be very familiar. We have the with scope function, and I'm just executing this piece of code and return with a landing page. We can run this example to see if it works. It did. I have one more example for DSLs for creating WebDriver instance. So here I have a Chrome driver that is being created with a DSL function. And I think you can figure out what's happening here. It's very common that we set some flags for initiating the driver. Typically, you set the incognito or start maximized, or accept insecure certificates, or let's see what else we can do here. Browser version, page load strategy. Essentially, everything is available here, and the IDE is very helpful because it tries to prioritize the relevant functions and properties on top. So I can just pick what I need. And for example, I can create a driver service here, and I can specify the port if I want. And the really nice thing is that I cannot misuse this API. Because if I'm doing something bad mistakenly, like this, when I place the driver service in the wrong place, it will not compile. So it forces you basically to use the APIs in the correct way. And the rest of the test is pretty much the same as before. So let me run this one as well. Oh, it was super quick. It passed. So the idea of the DSL is that you write code that is super expressive and maintainable at the same time, and it's very easy to create small DSL functions on the fly. And we have just arrived at the last part, which is the code generation in Kotlin with the help of KSP. So what is code generation? First of all, code generation essentially a metaprogramming where you have programs as your input and you create another program as an output. So typically you have some metadata in your source code. Those are the annotations. And you read those annotations and you do something with them. You can create, I don't know, documentation, or you might have heard of the Lombok Java library. That is a compiler plugin. And when you say add no args on top of your class, or add all args or getter or something like that, it will generate getters and setters, no argument constructor for your Java class. So you don't need to write those meaningless boilerplate code anymore. And KSP is a lightweight compiler plugin. It's not as powerful as full-blown implementation of a compiler plugin. The main difference is that you cannot modify existing code. You can only generate new code. And although the compiler plugins are much more powerful, but also it's way harder to maintain. They changed a lot over time and not so well documented. But luckily, Google in 2021 released the Kotlin Symbol Processing, which helps you to write lightweight compiler plugins, as I mentioned. And the key difference compared to the Java equivalent is that you have access to the actual source code. So you can read the source code itself. So you can imagine your program code as a tree. It's called an abstract symbol tree. Abstract symbol tree, where you have branches and leaves represent your program code. And when you write a symbol processor, you walk through the code and you are doing something interesting whenever you need to do, or you are interested in some code element. So the nodes are the smallest units of the language grammar, and KSP let you to inspect those nodes to some degree and generate new code. So it might sound a bit abstract, but I will try to give you an example. So I will start with the input of this code generation. So I have an unknown class annotated with page at page, and I have some locators. And almost each are annotated with a locator strategy and locator name. And if I build this project, the creator will pick up the KSP because the KSP is registered in the plugins block. and start analyzing my source code. It notices I have this add page annotation, and it has some processor registered. So it will read this file, figures out, okay, I need to do something with these two files right here. And based on my implementation, it will create some page object or part of the page object. And I can use those page objects in my test. And I will show you how the generated code looks like. So under the build generated KSP main, here is the login and the landing page. And yes, this is very similar what we've seen before, but now I'm just generating these pages based on some metadata placed in annotations. If I don't put annotation on top, then it falls back to the ID or name locator strategy, and the name of the locator will be password in this case. So let's try to use this in the test. So I'm importing the generated landing and login page this time. The rest is the same. So if I run this, it will be working. Okay. But you might be wondering, okay, how does this even work? I mean, I don't have login page, right? I'm sorry, I don't have a login function in this generated file. It's just a repository of locators, essentially. So actually, what I was doing here, I was using the extension function that we discussed in the very beginning. So I'm taking this generated login page and I'm attaching the login function to it, and the rest of the code is the same as before. So that's the beauty of combining different language features and take advantage of this concept to make your code more expressive or maintainable. Although I would like to mention that most people do not write Kotlin Symbol Processors, because there is also maintenance cost coming with that. But this is particularly useful for library developers, or you have a nice use case. For example, you have hundreds of page objects with a lot of locators. Then you can just create these enums, annotate them, put the strategy on top of each field, and you just generate these and then attach actions after the code generation and use those functions in your test. That's the basic idea behind it. I'm going to show you one more example. So here I have the same code again. One thing though is different. So previously I was opening the page in my p-force method, but now I have removed that, and the page opening happens in this locators class. I have annotated the login page with the base URL, and now if I look into the generated source file, you can see there is an init function that is being executed right after initialization, and it will call the driver.get to open up the website. Okay, this is nice, but you might be wondering, okay, I said before that annotations are limited. You cannot write, dynamic locators with them. And that's true, but you can, work around this limitation. for example, with mustache template. So what I have here is an export that takes some color and some shape. I will show you the website. This single static page. And what I'm trying to achieve here, I want to find all the cells with different color and shape and verify these texts. So I want to do this dynamically. So with mustache template, I can generate page object that actually has some function that takes a color and a shape and dynamically look up these web elements. So in my code, on the color side, I can do something like this, where I have the table page, and I have two enum classes, one for the colors and one for the shape. And I just iterating through them and trying to find the content of each cell. And in the end, I'm just verifying if they have the right name and the right color and the right shape. Let's run this one. Okay, this was super quick and we haven't seen anything because I have these on. Let's run it one more time. Okay, it did open, and yes, as you can see, it has passed. I think this is pretty much what I wanted to share. I hope I managed to spike your curiosity to explore Kotlin and its various concepts and features. But before closing my presentation, I would like to mention some resources. For example, this Kotlin in Action book, which is being written. So it's early access right now. I think they will finish it in spring. And I think only 2 chapters left. And chapter 13 covers the DSL constructions. And I think this is the best book if you are new to Kotlin and you want to get to know the concept and write idiomatic Kotlin code. And after some experience, you could get a book from Marcin Moskola. This is for slightly experienced developers. It assumes that you have some knowledge already. And I think this is also a very great book. It has chapters identifying different problems and giving solutions for each of the problems. And finally, if you want to explore symbol processing, I highly recommend this talk from David called with KSP Farewell to Stops. It's available on YouTube. And he will walk you through what you need to do in order to create symbol processing, because there are certain hoops to jump to set it up. And I think it's a very interesting presentation. And having said that, I would like to thank you one more time for inviting me. And it's a pleasure to meet the community. And if you have any questions, please let me know and I will try to address them. Yes, I will do share. And actually, I wanted to share one more thing. Let me bring back the sharing. So if you want to try out what I've been demonstrating, you can take this library from my GitHub page. It's called Colibrium, and you can just follow this guide and try to set it up and try to experiment it. It's very new. I just created this tutorial yesterday, and would love to hear some feedback if you happen to have something to share with me to improve, or if you are just interested in Kotlin and how to work with Selenium in Kotlin.
Atilia, any other any closing thoughts?
Try Kotlin out. Try to work with Selenium. I think it's a lot of fun. You can cut a lot of boilerplate. It simplifies your code a lot. The tool support is amazing. The IntelliJ team behind it and the Kotlin team, Google, are really pushing it. So there is a new IDE from actually JetBrains called Aqua. It's developed for testers. So
Okay.
you can actually experiment with that and write page object template when you create new page object classes. Unfortunately, as of now, it's a bit, it has some limitations, but maybe in the future they will open it up. So you could do more fun stuff.
Yeah.
Maybe some plugins to help your work and, cut your boilerplate even further.
Yeah. Thank you very much, Attila, for you too.
Thank you.